simple harmonic motion. So the simple harmonic motion is based on the motion of the spring So imagine that we have a spring here. We have a mass M. So if we have a spring, I put a mass here. So the force done by the spring, according to Hooke's law, and this is based on the Hooke's law, the force done by the spring according to Hooke's will be opposite to the displacement. So negative, because it's opposite to the displacement from the point of equilibrium. So negative Kx, where X is the extension of the spring. So when X is greater than 0, the spring gets extended, the force is in the opposite direction. So if you extend a spring this way, the force done by the spring will be in the opposite direction. So you know that. So the force done by the spring will be equal to, will be less than 0. The force done by the spring will be less than 0, negative, in the opposite direction. At the point of equilibrium, this is called the extension of the spring, extension, when X is greater than 0. X equals 0, the spring will be at the point of equilibrium. So the force done by the spring will be equal to 0. And finally, if X is less than 0, will be called compression of the spring, compression. The force done by the spring will be positive. Any system that obeys this, the Hooke's law, in other words, when the restoring force, the force bringing the object back to the point of equilibrium, is opposite to the displacement and directly proportional or proportional to X, to the displacement, will be called a simple harmonic oscillator. Any object that the force restoring means bringing back to the point of equilibrium. This is the point of equilibrium. If I just extend the spring, this will start oscillating. So the force that will bring back to the point of equilibrium, imagine that is along X, that restoring force, if it's opposite to the displacement and linearly related to the displacement, we will say that this will be a simple harmonic oscillator, any system that obeys that law, the Hooke's law. This is what we call the restoring force. In this case, we are studying the block spring system. We will study 3 systems here that are simple harmonic oscillators. One, the block spring system. The second one will be the simple pendulum. Also will obey this law. You will see that later. Simple pendulum. An object moving in the circle can be a third one, and a physical pendulum like the grandfather clock or a rod oscillating, physical, pendulum. These three systems are the ones that we will concentrate here. And also an object moving in a circular path also can be considered a simple harmonic oscillator. We'll follow that also. So let's concentrate on these three. Let's start with the block spring system. Again, the force done by the spring, as I said, is equal to negative kx, where k is the force constant or stiffness constant. It tells you how strong is the spring. So that k is based on the material of the spring. If it's stiffer, stronger, the spring, k will be greater. So k is a spring constant that is given in Newton per meter. Anytime that you see the spring has 100 Newton per meter, they are talking about k. How can we measure k? In the lab, we did a lab, very simple lab, which we did the following. We put the spring and we hang the spring at a normal length, this. The spring is at a normal length. I hang a mass. Immediately when I hang a mass, this will go down and will extend a certain amount. From here, from the normal length to here, a distance d or a distance x extension of the spring. So if I come here and I measure how much this will extend, because there will be two forces here, the force done by the spring up, the force by gravity down. In equilibrium, when this reach equilibrium, the force done by the spring will be equal to the force of gravity. The force done by the spring, the absolute value, because it's negative, will be negative times negative kx, because it's going down, right? Will be negative kx, but because x down is negative, we will say that negative times negative can be positive. Just we care about the absolute value. And this is a very simple way of finding k. K will be mg over x. This is a very simple experiment to find k. Now, my question is, if k under this weight, x, is greater, what will happen? What will be the spring? Stiffer or weaker? If under the same mass, under the same weight, this will go a longer way, what do you think? K will be greater or less? Greater. If x is greater, k will be less. Means that the spring will be weaker. Got it? Because x increase a lot. So under the same mg means that is less, less stiffer. If x is very small, like in the shock absorber of the car shock absorber, the spring constant is very high. How much x, how much is the compression of the spring in a car? Very small, right? Means that the spring that they have are much stronger than this spring. You understand what I mean? So this is the spring constant. The unit, Newton per meter. Good. Additionally, the second thing that we need to know is how to get the